Good afternoon. This is Mrs. Z. This is grade 5, mission 5, lesson 15, and it is a problem set. Okay, there are several problems that we're going to solve. Question 1. The length of the flower bed is 4 times as long as width. So the length is 4 times as long as width. If the width is 3/8 of the meters, 3/8 of the meter, what is the area? That's the question. So if you think about for area equals length times width. So this says that area here, they say that length is 4 times as width. Okay, so 4 times width is length, and then times width again. So how we can represent this is this without a this is expression to find what is the area of that flower bed. Okay, so if I choose width to be, let's model it. So if I choose, I'm going to go all the way to the end. If I choose this to be my width, okay, so that is width equals 3/8 meters. 3/8 meters, then I need to show that the length is 4 times as much. So if I choose this to be like 1/2 inch, I can also say that this is 1 time, then 2 times, then 3 times, then 4 times. So this is width, 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 and width. So width is this way, and also this is width, and this is 4 times width. So this here is value of L. So when I know that, I can make the area. So I know now that length is 4 times 3/8. So if I do 4 times 3/8, I can use that I changed the 4 into fraction form times 3/8. I can simplify 4 and 8 by dividing by 4. So that 8 divided by 4 is going to give me 2. And 4 divided by 4, I'm going to get 1. So right now I have 1 times 3 is 3, and 1 times 2 is 2. So 3/2, and 3/2 is really 1 whole and 1/2. So I've got, and that is meters, 1 whole meters and half. So that is the length. So length is 1 whole and 1/2 meter. When I have that, I can apply area equals length times width, or length times width, it doesn't matter. So 1 and 1/2 times 3/8. So I'm going to move this to the right. So now I'm gonna say area equals the 1 and 1/2 times 3/8. Okay. If I use distributive property, I can do this 1 times 3/8, so equals 1 times 3/8 plus half times 3/8, half times 3/8. So that equals 1 times 3/8 is 3/8 plus half of 3/8. 1 times 3 is 3, and 2 times 8 is 16. So I have 3/8 and 3/8 and 3/16 to add. I have to change 8s into the 16s by multiplying by 2. So I'm gonna get 6 16ths plus 3 16ths, and that is 9 16ths. Okay, so 9/16 meters squared, square meters. So that should be the area of this flower bed. Okay, let me make it smaller. Okay, so now this is answer for number 1. So 3 times as much. So that means if this is width, length is 1, 2, 3, 4 times as much. Okay. Let's see. Next, I'm gonna move to the number 2. Mrs. Johnson grows herbs in a square plot. Her basil plot measure 5/8 yard. Basil, okay, on each side. Okay, so Mrs. Johnson grows herbs in a square plot. This square plot. So her basil plot measure 5/8 on each side. So 5/8, 5/8, 5/8, 5/8. So 5/8 yard, and then 5/8 yard. Okay. Find the total area of basil plot. So if this is basil plot, I need just to multiply what is 5/8 by 5/8. So area of basil equals 5/8 yard times 5/8 yard. Okay. So yard times yard is a square yard, and 5 times 5 is 25. 8 times 8 is 64. So it is 2564 square yards. So that is a base, this part here that I color yellow. Okay, now I am going to do B. It says Mrs. Johnson puts a fence around the basil if the fence is, so she put fence around the basil. If the fence is 2 feet from the edge, 2 feet from the edge of the garden on each side, what is perimeter? What is the perimeter of the fence in the feet? Okay, so Mrs. Johnson put fence around the basil if the fence is 2 feet from the edge of the garden. 2 feet from the edge of the garden. what is perimeter of the fence fence in the feet? Okay, Herbiscur plant. His blood is on each side. On each side. So now I am a bit confused about what would be the picture of it if it's 2 yards. So if I add on each side 2 yards, okay, I got it. I understand this. So if I think this to be, let me see if this is, I'm going to use the square here. If that is number B, I'm going to make it. So the B is 5/8. Okay, and now I need to add about 2 feet on each. So let's pretend this is here and here and about here and here and here and here and also up there. All right, so 2 feet away, so it should be something like that, right? So this, what she wants to be around, oh, messed up this one. All right, so what would be, it's 5/8, so I need here add 2 more feet and here 2 more feet and here 2 more feet. Here's 2 more feet. 2 more, 2 more. But because this is 5/8 of a yard and this is feet, so that's the considered the problem, because I need to show how much is 5/8 in the feet. So I can add 2 and 2 and 5/8 as the, because this is right now yard, but and these they said are feet. So because of this, so now how we can change it? So if I have 5/8 that are yards, one, I can see this as 5/8 times 1 yard. But then if I change the yard into feet, I will know how many feet is that. So I'm going to need it to do 5/8 times 1 yard is 3 feet. So 1 yard is 3 feet, so times 3 feet. And that will equal to 15/8 of feet. Okay, so now 15/8, 8 plus 8 is 16, so it's not 2 feet. It is less than, so it has to be, that is 1 whole foot, and then 7/8 of the next foot. So right now, I got the value of what is 5/8 as a yard, 5/8 yard as a feet. So now I know that I need to add 2 plus 1 and 7/8 plus 2 to know what is the length of the of this square around the basil that represents the fence. So the L equals 2 plus 2 is 4, plus 4 plus 1 is 5, so it's 5 and 7/8 feet. now I know that the fence is from this point to this, it is 5 7/8 feet. Okay, and because this is a herb is square, the shape is a square. If I add 2 feet all around, that is also going to be square. So this is also square. And if I needed to find the perimeter, which is they are asking us, so it will be the 5 7/8 plus 5 7/8 plus 5 7/8 plus 5 7/8. So the perimeter for the square, P for the square, equals 4 times 5 7/8. So 4 times 5 is 20, plus 4 times 7/8. 4 times 7 is 28 eighths. So 4 groups of 7/8 is 28 groups of 1/8. So now I'm thinking, okay, so 3 times 8 is 24. So this is also going to be, if I decompose this into parts, I can make 24 eighths will make me 3 whole foot, plus the 4 eighths will be extra. So 24 plus 4 makes 28. But I separate them because this will make me 3 whole feet, and then this will make me half of 4 is a half of 8. So I know then this is this, and or it's also 3.5. So this represents 3.5. So finally 20, and this is now this. So together is 23.5 feet. Because we're not calculating area, we're calculating perimeter, and perimeter are the feet around that represents the fence. Fence is perimeter. So this is answer for B. The A was this, and then B is this. Okay, let's look for this one, which is E. What is the total area in a square feet that the fence encloses? So fence gonna enclose total area. So now area is this is length times width, because it's square, is both is S times S or S squared. So area of that square is 5 7/8 times 5 7/8, and also feet, that is feet squared feet, because foot times foot equals the square foot. Okay, and then I can label this to be like S equal. So if I find the area of that, area is S squared, or S multiplied twice. So let's do the distributive property. So we're going to do this 5 plus 7/8 times 5 plus 7/8. Okay, let's do 5 times 5 and 5 times 7/8. So 5 times 5 plus 5 times 7/8. Now plus, okay, we're gonna do 7/8 times 5 and 7/8 times 7/8. Okay, so 7/8 times 5 plus 7/8 times 7/8. Okay, let's go solve it. 5 times 5 is 25 plus 5 7/8. 5 times 8 is 35, so it's 35/8. And it's same here, 5 times 7/8 is 35/8. I'm going to do on the side to calculate how much is 30. So if I separate this 7/8 times 5 as a fraction, that would be 35/8. So now I can do 8/8. So it would be 4 times 8 is 32. So 32/8 plus 3/8. 32 divided by 8 equals 4. And then 3/8 is left. So this is what 5 times 7/8 or 7 times 5/8 is. So it's a 4 and 3/8 plus 4 and 3/8. And then last one is 7 times 7 is 49. 8 times 8 is 64. So that is 49/64. Now I need to change these. This is 4/8. If I do 4/8 plus 4/8, that will give me, let me use this, here is 4 and 3/8. I'm going to use 4 and 3/8 plus 4 and 3/8 is 8 and 6/8. So this is 8 and 6/8, but 6/8 I can change into 64ths to add to the 49. So I can do 6/8. So I'm going to multiply by 8. So 6 times 8 is 48. 8 times 8 is 64. So this here, all this is going to be, it's going to be 8 and 48/64. So 8 and 48/64 plus 25 wholes still, and then plus this 49 49/64. Now, the pieces are the same. Okay, so as you can see, this I calculate on the side. I add, if you can see, sorry, 4 and 3/8 plus 4 and 3/8. It was here. It becomes 8 6/8, and then I change 6/8 into 48/64. So the final answer is 8 and 48/64 or 48/64. So that is right here. This is that. And I need to add now 48 plus 49. So 48 plus 49, that is 97/64. So that is equals 25 plus 8 wholes makes 33. and 97/64. So because the whole is made of 64, I have a 64 and 97. So I can see that 97 minus 64, that will make 9 minus 6 is 3. So 33 left. So I will make one whole from this, and I will have 33 64ths left. So finally, this is equal to 34 wholes and 33 64. Now we have a square feet squared. Okay, I have no room to write, so I'm just gonna take this like that, and I am going to rewrite that right here. So the area is 34 and 33 and 64, sorry, 64, and that is a feet squared. If I needed to answer this, I see that 33 is about half of 64. It's about half. So we can estimate that this is about 34.5 square feet. That's the final answer for this. If you needed to estimate, to round this answer, and that is answer to the E. Okay, guys, I hope you can see all of it. Lots of work, but okay, move on to the next one, right? Okay, here you go. Now I do have a Janet. Okay, Janet bought 5 yards of fabric, 2 1/4 feet wide, to make curtains. She used 1/3 of fabric to make a long set of curtains, and the rest to make 4 short sets. So 1/3 was for one set, long set. And then she uses the rest to make 4 short sets. If we think about this, Janet, about 5 yards of fabric, 2 1/4 feet wide, to make curtains. 5 yards of fabrics to make curtains. She uses 1/3 of the fabric to make long set of curtains, and the rest to make 4 short sets. Find the area of fabric she used for the long set of curtains. So the first, she has 5 by 2 and 1/4 feet. The fabric. So if I do and change this to be 5, and this is, let's see, 1.5. Let's see. Okay, I'm going to okay, and then 2 1/4. So if this is a 5 yards, and this is 2 1/4, let's see if that is 2. I'm gonna make it just pretending. So okay, so that is 2 yards, and this is 1/4 of a yard. Okay, so now I'm going to find what a whole area of the fabric that she has. So 5 times 2 is 10 squared yards, and then 5, this is 5 times 2, and that is area, and then 5 times 1/4 is 5/4 yard, 5/4, and 5/4 is 1 whole and 1/4 yard, square yard. So altogether, the area of the fabric, F for fabric, is 11 and 1/4 of a yard, square yard. So now we know total of the area, but then she uses 1/3 of this to make long curtains. So what that means is, so if this is the total, 1/3, like 1/3 of 11 and 1/4 will be the long set of curtains. So what is 1/3 of 11? So that is 1/3 times 11 plus 1/3 times 1/4. Okay, 1/3 times 11 and 1/3 times 1/4. 11/3. If you have a side work, you can say 11/3 equals, you can bubble this, okay, 3 plus 3 is 6, plus 3 is 9. If you add 3 more, that would be 12. So you can only make 3 holes here. 3 times 3 is 9, and there is 2/3 left. So this represents 11/3. Let's see, 11/3, and that is equal, so 3 holes and 2/3 plus, now 1/3, this is plus this one. Okay, I could do that 1 times 1, 3 times 4, and then this is 1/12 here. Okay, I just like making steps. 1/3 times 11 is 11/3 plus 1/3 times 1/4 is numerator times numerator, denominator times denominator. So 11/3 is 3 and 2/3. 1 times 1 is 1, 3 times 4 is 12, so this is 1/12. So adding now, changing the thirds into the 12s to be able to add. This 2/3 is same as 8/12s, and one more 12 is 9/12s. So final answer is 3 holes and 9/12s. And what the units are square yards. So she uses 3 whole square yard and 9/12 of the next yard to make one long set of curtains. And now and then the rest she makes 4 short sets. So what that means is she is going to she's going to divide this into 4 smaller parts. You can say 3 and 9/12 divided into 4, or we can multiply a reciprocal 4 to 1/4. So it would be the same. So the smaller would be 3 9/12 times 1/4. So, or 3 9/12 divided into the 4. So let's see. That means I have to do 3 times 1/4. 3 times 1/4 plus 9/12 times 1/4. 9/12 times 1/4. That equals 3 1/4 is 3/4, and that is equal to this is 3 3/4. 3/4 plus 9 times 1 is 9. 12 times 4 is 48. So now when we do multiply, we need to add now. This is fourths, this is 48. So I need to change the fourths into the 48. So times 12. So 3 times 12 is 36, and 48 plus 9 48. So 36 plus 9 equals 45 48. Yeah, square yards. Yard squares. Okay, square yards. So if you look this, it's about 1 yard. She will use square yard for each of these because 48 is very close to the 1 whole yard, square yard. So you can estimate about that. And then this is like 6 is half of 12. So this could be 3.5, or this could be estimated as a 4. Square yard. So 4 square yard for 1 long set, and about 1 yard for 2 short sets. Okay, let's see what we have. Now, find area of fabric she used for the long set of curtains. Oh, I did that, 3 9/12. But I did find area of fabric she used for each short set. I already solved the second problem here because it was find area of fabric she uses for each of the short sets. And that's what I come up with. So this is the answer A, and then this is the answer B. Okay, so I can write find area of fabric she uses for each short set. So she used about 1 square yard for each short set, and about 4 square yards for long set. Okay, so I used it paper to answer. That is Okay. Okay, got it. Okay, so let's see, that was number 3. Okay, let's move to number 4. Okay, number 4. Making it a little bit bigger. Okay. Some wire is used to make 3 rectangles. A, B, C, and C. Rectangle B dimensions are 3/5 centimeters longer than rectangle A's dimensions. Okay. Rectangle C dimensions are 3/5 centimeter larger than rectangle B dimensions. Okay. Rectangle A is 2 centimeters by 3 1/5 centimeters. So let's see. Some wires are made to make 3 rectangles, A, B, and C. B is larger than A for 3/5, and C is larger than B. So that logic says to you that A is the smallest, B is a little bit bigger, and then C is the largest. So let's see if I use this and make that. All right, I'm gonna make this rectangle, and that is going to be A. And then I'm gonna make, let's see, a little bit bigger, not too big. I'm gonna improvise. That is the next one. And this would be the largest one. Okay, so I did this. This is A, this is B, this is C. So we know dimensions for A. A is 2 by 3 1/5. So it's 2 centimeters by 3 1/5 centimeter. So this is 2 by 3. Because it doesn't say time 3/5 times, it says 3/5 centimeter larger. So the dimension 2 is larger for 3 plus 3/5. So if I look this, B is larger than 2 by 3/5 centimeters, so it would be 2 3/5 centimeter, because it's plus. And now 3 1/5 plus 3/5, that will make 3 4/5. 3 4/5. So how that I know it's like 2 plus 3/5 equals 2 3/5. And then 3 1/5 plus 3/5 equals 3 4/5. So now I know this length for the B. Okay. Now this C says C rectangle is 3/5 larger than rectangle B. So now I have this 2 3/5 plus 3/5 equals 2 6/5, which is 6/5 is 1 whole and 1/5, so it's a 3 1/5. So this one is 3 1/5 centimeter. And then the length that is going to be, I just use the rectangle squares, but the shape is rectangles. They're not. So you don't need to really, I didn't do precision, so that's okay. It's just I'm having rectangle right here. Square is rectangle, by the way. Okay, so 3 4/5, 3 4/5 plus 3/5 equals 3 7/5, 3 7/5, which equals 4 wholes and 2/5. Okay, so now I know the length for here. So this is 4 2/5. They're all centimeters. So now I know the measurement. This says what is the total area of 3 rectangles. So I need to find the area of each rectangle, and then we need to add them together for all 3. We need to find what is the area. So if I say, let me make a lighter. So area A equals 2 times 3 1/5. 2 times 3 is 6, and 2 times 1/5 is 2/5. So, and that is centimeters times centimeters is squared centimeters. Okay, now area B is 3 4/5 times 2 3/5. Now, if I use 3 times 2, I'm going to rewrite that down. 3 times 2, okay, plus 3 times 3/5. 3 times 3/5 plus 4/5 times 2 plus 4/5 times 3/5. And now I'm going to calculate it. Sorry, couldn't see this. So let's see. 3 times 2, 3 times 3/5. 3 times 2, 3 times 3/5. 4/5 times 2 and 4/5 times 3/5. Okay. 3 times 2 is 6, plus 3 times 3 is 9/5. 9/5 is 1 whole and 4/5. Plus 4/5 times 2 is 8/5. So that means 2 times 4 is 8. 8/5 is 1 whole and 3/5. And then 4 times 3 is 12. 5 times 5 is 25. So now 4/5 and 3/5 is 7/5. So 7/5 will make another whole, and I will have 2/5 left. So if I go and say this is 6, 7, 8. 8 and 4 and 3 is 7/5. So that would be 9 and 2/5 plus 12 25ths. I hope you can understand this, because this and this are the fifths. So 4 plus 3 is 7/5. 5/5 makes a whole. 2/5 is left. So we have 6, 7, 8, and one more is 9. 9 and 2/5. Now I'm changing the this by multiplying by 5, so numerator and denominator to get me here 9 and 10 25ths plus 12 25ths. So finally I got that answer that is, okay, 9 and 22 25ths. 9 and 22 25ths. What? Square centimeters. Okay. Okie dokie. So now I hope I have room for the C to do here. So what do I need to do? If I do C, its area of C equals 4 2/5 times 3 1/5. So area equals 4 times 3 is 12 plus 4 times 1/5 is 4/5. Okay, plus 2/5 times 3 is 6/5 plus 2/5 times 1/5 is 2 25ths. Okay, let's see if I did correctly. 4 times 3 is 12. 4 times 1/5 is 4/5. 2/5 times 3 is 2 times 3 is 6/5, and 2/5 times 1/5 is 2 25ths. Okay, so did that. Now let's change the values. So here I have 4/5 and 6/5. 4/5 and 6/5. They will make 10/5, and 10/5 is 2 wholes. So practically I have this 12 plus 2 is 14, and 2 25ths squared centimeters. So I had to shorten it, my calculation, because of the room. I would rather have extra paper for you. If you're doing it in classroom, use the notebook to do so. So you have enough room to do. But so far, I have all these 3 areas. But that's not it, because they ask us to calculate what is the total area of the 3 rectangles. So the total area, I have to use my margin on the top. So I'm going to add area total equals, okay, 6 2/5 plus 9 and 9 22 25ths plus 14 and 2 25ths. Okay, and that is all square centimeters. So I'm going to change, these are 25ths and these are 25ths. So I'm going to use this 5 times 5. So this will become 10 25ths. So this is 10 25ths. So when I add 10 25ths and 22, that's 32, 33, 34 25ths. So I will have 34 25ths. So when that I change, this will become 25 25ths plus this 34 minus 25 is 9 and it will be 9/25. So it is 1 whole and 9/25. So what I did is I add this part fraction and this fraction and this 2/5 when they become 10/25. So then I exchange the improper fraction into mixed number. So now I'm going to add these together. So it would be 6 plus 9 is 15 plus 14 plus this 1 and 9/25. So 15 and 1 is 14 and 1 is 15. 15 and 15 is 30. So it's 30 and 9/25 square centimeters. So this would be a total of square centimeters. This is the total area of these three rectangles, the rectangles wire. Okay, so let's make it smaller. It looks like a windy outside. So that was problem 4, but only A. Now we are working on the number, it's B. So they say now, if a 40 centimeters coil of wire was used to form rectangles, how much wire is left? How much wire is left? So imagine this was made of wire. You start from here and you go around and use the wire. And here you start and bend the wire. So that's what they do in real life. So right now I need a perimeter for A, perimeter for B, and perimeter for C to know how much wire they were using for each. So perimeter is adding 2 lengths and 2 widths. So if I know, so that what that means is I'm going to add 3 1/5, and then again 3 1/5, and 2 and 2. Or in some way people do, they find out what length and width is, and they add twice, because 2 plus 3 1/5 is 5 1/5. So is this side also 3 1/5 plus 2, that is 5 1/5. So right here is 5 1/5 and 5 1/5. So that this perimeter should be 10 2/5. But let's see how it's done. So if I have a perimeter A, so it doesn't matter if you think anyway, you can do like, look, you can do 2 plus 3 1/5 plus 2 plus 3 and, oh, sorry, I messed up, 3 1/5. Okay, so what people can do, you can say 2 times 2, or you can do 2 times 3 1/5, or you can associate these two and these two, and then you can add on the total. So if like I said, this is 5 1/5 plus 5 1/5. So the whole perimeter for this one is 10 2/5. But because we're talking about perimeter, we're talking centimeters around, so it's only cm, it's not a square, it's a centimeter. So we are calculating this centimeters length. So that's perimeter A. So now let's do perimeter B. Okay, so I'm looking measurements for perimeter B. I could do 3. 3 plus 2 is 6, and 3/4 and 3/5 and 4/5 is 7/5. So I'm going to 2 times Let me change 2 times, and I need 3/4 plus 2 3/5. That is equals 2 times. This is 5 7/5. 5 7/5. So that is equals to 2 times 5 is 10 plus 2 times 7/5 is 14/5. Oh, sorry, you cannot see that. I apologize for that. Okay, so this was perimeter of A rectangle, and this is perimeter of B. I did 2 times one, the length plus width. So length plus width twice. So two, and then 3 4/5 plus 2 3/5 is 5 7/5. So 2 times 5 is 10, and 2 7/5 is 14/5. So now we have 14/5 is 2 wholes and 4/5. So that is 12 wholes and 4/5 in only centimeters cm. So I make it a little bit smaller because it seems like you can see. I think this is good. Okay, so perimeter A, perimeter B, and now perimeter C. Okay. So, you can also do, if you like, you can do 2 times 4 2/5 and 2 times 3 1/5. And then you can also get the same result as adding these two and multiplying twice. So I'm just going the different strategy to find perimeter. I just need to add all the sides around, that's all. So if I use the next measurement, it would be 2 times 4 2/5 and plus 2 times 3 1/5. Okay, this is this different approach. So 2 times 4 is 8, and 2 times 2/5 is 4/5, plus 2 times 3 is 6, and 2 times 1/5 is 2/5. Now I get here 8 and 6 is 14, but I have here 4 plus 2 is 6/5. So that means that makes one more. Let me make this for you. 8 plus 6 is 14, plus 4/5 and 2/5 is 7/5. So that is equal to 14 plus 1 plus 2/5, which is equal to 15 2/5 centimeters. So right now, I do have perimeter for A, perimeter for B, and perimeter for C rectangle with wires. They say if 40 centimeters coil of wire was used to form rectangles, how much wire is left? So if I add all these, I will know how much that was used to make these rectangles. And then if I subtract from how much was you had at the beginning, then we will find what is left. So 10 2/5 plus 12 4/5 plus 15 2/5 equals 10 plus 12 is 22. plus 10 is 32, plus 5 is 37. And now, if I'm wrong, 12, no, I didn't. Good. Okay, 2/5 and 4/5 is 6/5. And 2/5, that means is 8/5. So 8/5, so plus 8/5. So when I have 8/5, I do have 37 wholes plus 1 whole and 3/5. So the final is 38 and 3/5. That is a total wire used. Okay, so if 40 kilometers of wire was used to form this, how much is left? So they had a 40 and they use 38 and 3/5. So the answer is how much is left. Because we can say 40 minus 38 without problem, but we needed to regroup 1 centimeter to make 3/5 to take away 3/5. So how I do that? I will take and leave 39 whole centimeters, and I will have 1 centimeters to create into fifths, because this is the key. We needed to have a fifth. So 5/5 is the whole. This is also 40, because 39 plus 1 more is 40. I did not lose any. I just regroup, so I can subtract 38 wholes and I can subtract 3/5. So now 39 minus 38 is 1, and 5/5 minus 3/5 is 2/5. So centimeter, so that is left. So this is how much wire is left. 1 and 2/5 centimeters is left wire. Okay, guys, that was B for problem, and I think we are done with this. That was lesson 15 problem set. Okay, let me make it smaller. Okay, that was okay, and then all right, that was Mrs.Z, and lots of work. Okay, see you next time. Thank you for listening, guys, and forgive me if I made some mistakes. So far, I think I did good. Okay, this time, just perfection. Sorry, this is 3. Oh, there you go. Have a good night. Bye, guys.